Ladies and gentlemen, the President of America! President Camacho!
Shut up! Sit your monkey ass down.
Hello and welcome back to COE live streams for a School of Entropy awesome time, learning, sharing, caring time. Oh yeah, you can go ahead and unmute. And we have some very eager learners with us tonight. Aaron and J. D.
JD.
What's up?
Thank
How's
you
it
to
going?
all who are joining us. I will share the link now that we're live and good to go, and we can have a chat. I don't have anything sharing in the comments
you-
right now, so we'll see
How
if
many
anybody
people
shows
are
up.
you expecting?
It's
are
the
you
middle of the
expecting-
night, isn't it?
Yeah, I know. I mean, like, you're not expecting like the Sunday audience, right?
Well, if people show up, I'll share the chat, and if not, I won't. So we'll just see. I have no idea how many people, but I will put it out on social media.
All right, but we're gonna go with the assumption this is mostly something that people are gonna watch later. Like, hey, I want to learn the same thing that these people are learning.
Well, calculus
Right.
is a great place to start.
Yeah. Well, I think trig is where unless you just want to fast forward, and I'll just sit here.
Well, we're not. We can't jump immediately into calculus.
Yeah, I
We have
wouldn't
to
think
first
so.
figure out where Aaron's at in his quest. So we'll just
Yeah,
ask
and I
him a
have
few
no idea how
questions. So,
serious he's being.
what is 2 plus 2?
That's where
Oh,
we,
yeah.
yeah.
Yeah, do we need to review arithmetic?
Because if 2 plus 2 equals 5, I'm already out. Like
Yeah.
I'm done.
Do you remember? Do
I'm
you
totally
remember
confused. I was
Well,
totally
you know
relying on
why 2
before.
plus 2 isn't really 4, though, right?
No, it's just
Because there's no real likeness. Like, adding presupposes a likeness that doesn't exist in the concrete realm.
Mm.
So even on that level, like, it's still very much an abstract concept.
That means I'm already gone. I'm out. Like,
Okay, if let's say you
already
have
failed.
a bushel of apples, okay? And I say, how many apples are there? And then you count them up. And then there's like 40.
yeah.
Are they really 40 apples? Or are there
Yeah.
40 apple-like entities? And how apple-like are they truly? Like, the question is, are they fungible? You know what that word means, right? Fungible?
No. Is it like it manipulate? You can manipulate it? I don't know. Fungible.
Okay, it's okay. It's good. It's good to, even if you're not sure, sometimes it's good to just take a guess to keep the convo going. Do you know what fungible means?
Wait, maybe we should, like, if we're gonna do, like, with me being, like, maybe people should know that I had a stroke, that, like, a lot of my knowledge has been completely erased.
Really?
Yeah. That's why we're here. We're here to rebuild my mind. That's what I thought the idea was.
Well,
And that's
yeah. I
the plan?
mean,
Church of Entropy says she can rebuild my mind with
Mhm.
math. And I'm
all right.
Good
I'm all
start.
for it.
Rebuilding the Man, Jesse Lee Peterson. Rebuilding the Mind with Jen.
It's
So
worth
anyway,
a shot.
I had no idea what you said. Like, I knew if I brought up 2 plus 2 equals 5, I'd already be, like, not able to, go along with you guys. Like, to me, 2 plus 2 really equals 4. I just can't see any other way.
It does
I think
equal
it-
4. It's
yeah, she's
definitely
just
4.
telling
No one's
you
saying
the,
it's not 4. But the reason it's 4 is because they're fungible units, which don't exist in IRL. Like, hardly anything's fungible IRL, is my point. And then I said, do you know what fungible is? You said something you could manipulate that I wanted to know if maybe our other guest wanted to take a crack at what that
what
word meant.
fungible means?
Yes.
You can manipulate it, no?
That sounds
Yeah.
right, but
Damn it, I don't know what fungible means. Funge.
Here's what you want to
Fun-
do. Let's just take a deep breath here
It
and just
it
focus
sounds
on
delicious.
the point. We're going to focus on the point like just above the head. So it's like almost like you had a you know what growing out of the top of your head.
mm-hmm.
That's what
I
we're
don't
going to do.
I don't even know what, a horn? Or are you talking about something else more
Well,
phallic?
you know, use your imagination. Those metaphors are all
the
fungible.
most phallic thing possible.
Those are some fungible metaphors right there. Basically, that you can swap one for the other.
Okay.
So if you get an ounce of, they usually talk about it with like precious metals. That one's basically the same as another. That's what fungible is.
Yeah, when there's like countability is one way to think of it.
The
you know,
point is
discrete-
that the distance from 1 to 2 and the distance from 2 to 3, that's the same, right?
Yeah.
Each number is in what it is fungible with every other number. Like you can get to any number by just adding ones to get to that number, right?
Mm-hmm. I
Yeah.
agree.
So that doesn't analogize to real life. There's nothing in real life, really, hardly anything that's fungible this way.
Yeah, but
Elements.
like, yeah. I was gonna say like if you get down to like quarks, or I mean that's kind of like it's part of what the science of the small is all about. Is like where do you come up against things that are absolute or pure? You know, is it strings? Is it quarks? Is it
Well, we're not even talking about absolute yet. We're talking about fungible. And that's
Okay.
really important distinction, because we want to be clear about where math actually applies, because if we start to believe things about math that aren't true, it makes it harder to learn.
Well, yeah, like math is not an absolute truth.
Math is absolute, but the world is absolute as well, but actually not in the same way math is.
Or well, well, I guess what I'm saying is you're abstracting something like with the apples example. You know, it's 40 in the way that we can all agree it's 40, but is each one actually the same? Of course not. Right? But we're pretending that they're the same so that we can like have an economy. And
on what basis do we presuppose fungibility is the point. So it's like, we can presuppose fungibility. That's what money is. We can presuppose fungibility with money. That's what it is. That's literally why it's a thing.
Yeah, and Bitcoin really demonstrates that, because it's all about literally signing over, like a Satoshi, which is the unit.
Well, that might be a scarcity thing, but even that, we're getting to a higher level of abstraction. So what do you think my point is in this mini ramble here, Aaron? Honestly, if you don't know the point, that's fine too.
To confuse me. You don't need to do that, like pre-confused.
The point is to tell you that math will get more confusing if you believe that it has a range of applicability that in actuality it doesn't. Math really doesn't describe anything in a way. And my apples example was a point. Like apples are actually a little bit fungible. Like
a little bit.
Like if you get down to it, it's like is a McDonald's burger fungible? It's like, well, it's probably different bugs and rats, but it's like pretty much the same.
They're attempting to make them fungible.
There's like a fungibility spectrum.
Mm-hmm.
So the apple is like less fungible than the Big Mac, and then the humans, how fungible are people? Sort of
Sometimes they're called tolerances, right? The like when you're manufacturing.
Tolerance is another level of abstraction. I don't want to confuse Aaron. Does this make sense yet, Aaron? What I said?
No. No.
All right. So what's 2 plus 2?
If I'm racist or not racist.
Okay, this is not the way to go to be having a serious discussion here.
I thought it's racist to say it's 4.
I really don't know what you're talking about. But
That's what
unironically, I do need to know what your skills are in math. So should
Okay,
I ask a different one? What's 2 plus
I guess
3?
I'm a racist. I would say 4. I think 2 and 2 is 4. That's what I would go with.
Well, I guess we need to take a break so you can go flagellate yourself. Do I need to play a clip video?
You're saying like nothing really represents anything, so 2 plus 2.
I didn't
equals
say
whatever you
nothing
want it to be.
represents anything. I didn't say nothing represents anything. I said that
Nothing is truly fungible.
there are some things. What I was alluding to was that fungibility is on a spectrum, and on the limit you have the elements where you can
I
say
think
yeah,
you're
they're
on the spectrum,
fungible.
yeah.
They're truly fungible. Like if you have 10 oxygen atoms versus 10 other oxygen atoms, right? They're indistinguishable.
I'm looking up the definition.
Good.
Let's see.
That's what we should be doing. You know, have something open to go and do some research. That's part of the fun of it.
All right, so the exact definition from our friends over at Merriam-Webster is being something such as money or a commodity of such a nature that one part or quantity may be replaced by another equal part or quantity in paying a debt or settling an account. 2, which I think is what we're really talking about, is capable of mutual substitution, interchangeable. And then there's a third one that doesn't really apply. Do you want me to read that too?
Yeah, we don't have to read them all.
Doesn't fungible sound delicious? Wouldn't you love a
It's
cup
actually,
of fungible-
it's actually
Sounds pretty
the exact
darn
opposite.
hallucinogenic
It's
to
the
me, to
opposite
be honest.
of what we both thought. It's the opposite because we were thinking it meant, you know, like it's like ephemeral or, you know, like it you can mess with it. Chain, you know. But yeah, it's the exact opposite of what we both guessed.
I'm not trying to confuse you. I'm trying to get you in the right headspace so that it's not confusing when you go to learn it. Because I've taught math to a lot of people. And most of what slows them down is it's not the rational, it's the emotional, disturbing the ability to think rationally. It's like, oh, am I too dumb? Oh no. It's like the deciding
brain,
factor is
right
how
brain.
comfortable you are feeling dumb. Not
You just
to
let
sound
your-
like
let your
Einstein or
right-
anything.
Let your right brain take over.
No clue what that means.
Isn't the right brain the one that's like logical and it
Yeah, but like quantum mind does not
just does
predict
it.
that.
does its
It's like,
best?
why would there be a right and a left? Why would that?
I don't know, I'm
literally,
just-
what the hell does that even mean?
I'm just talking about what I saw, you know.
Back to the calculus. So we have
Okay.
to do something called algebra. So, Aaron, do you know anything about algebra?
I mean, I did know algebra.
What if I say 2x equals 4?
2x equals 4. The 2x equals 4. 2. X equals 2.
Yeah, solve for X too.
There you go.
If you're racist.
Yay! So there you go. And like that can go up and up and up. That's a basic relation,
And that
right?
concludes this lesson.
So if I say like 50x equals 100.
It's still 2.
2.
You just couldn't help yourself, eh? You just had to say it. Right. So there you go. That's
Wait, what did you want? What did you want us to do?
I was asking Aaron. He's the
Oh,
one who's
sorry.
brain damaged. You're just like too excited.
No,
It's fine. It's good to be excited.
I said 2.
Wait, I think didn't you say it first or no?
I
I'm
said-
sorry.
Yeah, I said it.
joking.
Give another example, and I won't say anything.
Okay. 3x
But make sure the answer is 2, though.
3x equals 1.
2. 3x equals. All right, 3x equals 1. It's a third.
Nice one.
Boom.
The Trinity smiles down upon ye.
I am feeling so racist right now.
That's such a hateful word. We don't want to spread hate on this channel.
I was shocked that 2 + 2 = 4 is racist. I didn't think that I was racist until that point.
Yeah, whenever someone calls me racist, I'll just say that, Jen. I'll be like, "Hey, that's a hateful word. I don't appreciate that. Spreading negativity."
Well, I prefer to spread positivity. Okay, so we're basically on the path to quasi-understanding multiplication. So I guess the next one up would be like, how well do you know your times tables? 7 times 7?
49.
Okay.
Wait, is that it,
12
right?
Yes, that's
Yeah.
correct. 12 times 11?
121.
I don't even know if
So
that's
that-
right. I guess I should ask the ones I actually know the answer to.
I used to be the math.
12 times
JD, you
11
check.
is,
JD, you be the checker. You check.
Well, hold on.
Get the
12
TI-83 out and
times
check.
12 times 12 is 144 minus 12. That's because I remember
Just
all
give us
the
a couple
squares.
minutes, guys. We'll be right with you.
I've always been good with the squares and stuff. I think I know pretty much all the squares, but and then I just work backwards from there.
The thing is, if you're going to use the hateful defense, you can't then turn around and say stuff that's
The what defense?
what you said about using the not liking hateful language thing when people call you racist. It only works if you don't then turn around and espouse a bunch of hateful rhetoric, right?
Yeah.
You can't just be like, fuck off, everybody, and then after 2 minutes be like, you're mean. Well, I guess you can be like that, but
I was just joking, but yeah.
yikes. I should have checked the chat before sharing it, but I guess there's enough people watching now.
Oh wait, hold on, let me pull it up. I can't see any of this. Like, what? Are you trying to show me stuff or not?
No, I'm just sharing the chat because there's some people who showed up.
Yeah, but
And-
you're sharing it through OBS, which I can't see.
If
Okay,
you
I can
want to
use-
watch, you have to watch. It's about 30 seconds behind, maybe, but you can just open the regular YouTube as long as the audio doesn't come through.
Okay.
You can like mute it and just watch it in real time. I'm assuming that's what Aaron's doing there.
Oh my God, there's a
Yeah.
there's a Gen stream. Let me see.
Uh-oh. Yeah, I
Alright,
have
so
I have like
mute it.
if you guys didn't show up, I was just gonna go through this. slide.
HIV positivism is being spread here.
More math, guys. Come on, let's get on the. I need more
You
math.
derailed this with the R word. Let's move forward in peace here. All right. It looks like. All righty. What's next? So we feel okay about the times tables? Pretty good.
Yeah,
Not great.
yeah.
Wonderful.
Actually, I'm feeling pretty good about the times tables.
I
I was
don't
a
really-
master.
I don't really think you
Yeah.
need to like use them too much, but just the basic premise of adding, multiplying and dividing, that's super important. All right, so next step would be isolating a variable.
No, that sounds way too hard. There's got to be a step in between
You
that.
already literally did it once when I said 2x equals 4. So you just isolated a variable without even thinking about it. So what you need to learn next is the structured approach to
Wait, you actually labeled
isolating
it
a variable.
calculus, so people are like, "Why the fuck are you going over?" You shouldn't have labeled it calculus.
I put,
they're gonna
excuse me, I
complain.
put preparation.
Oh, okay. Well, so then, we're stretching the meaning of that word to the max.
I put a preparation there. Okay, I'm sorry, but if you should see some of the stuff getting passed off as titles these days on the
And
internet.
I'm just saying, knowing your audience, they're gonna be mean about
They're
it.
gonna be like, "Oh my god, there isn't any calculus on this thing." I really don't think they're gonna do that because
Yeah, someone already did. What do you mean? They're not.
if they
gonna
really
do it.
cared, see, but that's disingenuous, right? It's like, who has actually come on the show to ask questions about calculus other than literally the one guy who was like a physics, mathy, university, like semi-prof?
Well, yeah. So in reality, they're here to just listen, and they don't.
Well, they could come on the channel literally anytime to ask calculus questions, but now it's like, oh, now that this is happening, that I
Yeah.
think this thing I didn't know I cared about until 2 seconds ago. Can we go right to
Yeah.
calculus, please?
Yeah. Hey, I just want to learn stuff, so it's not.
Well,
I'm
yeah,
just
we're
going off
getting
of
to a method of learning something. So, have you screen grabbed the Chatteroo or the YouTube thing? Can you see what's on YouTube right now?
I'm looking at science and number theory was well understood in antiquity through the oral tradition. To date, cultural degradation and military conflict have made it impossible to bring full spectrum.
Oh
of
yeah,
this
that.
ancient
Yeah, you
knowledge
don't have to
in
read that. You don't have to read that. I wasn't
Okay.
planning on going through all this stuff.
All right, well, like, what you're like?
I just wanted to know if you. I wanted to know if you could
don't look
see
at
it.
it.
No. I
Yeah.
was
Yeah,
just
I
asking.
can see it. It's on a delay, but I can see it.
Okay,
so.
awesome. It's gonna be tough if there's that big of a delay though. But I guess I can just improvise.
Well,
So
okay, so do you want me to tell you
open
what
one
I'm
paper.
seeing now, or why don't you pull it up too, so you can see what the delay is? Like, pull it up and mute it, and then you'll know what I see, right?
Do you see what I see?
Because I had the same thing before when I was like trying to watch stuff with people. Because I realized, well, if I'm like watching it live, then the other person is not going to know what I'm talking about. So what I would do is I would set it up, and then I would actually watch the stream with the person, and be on the same delay. It's, it sucks, but it's kind of like, I don't know how else we're going to do it, right? Unless you figure out a way to also share it through Google.
Or you could just write it down. There's that
Okay.
too.
But you just said you
It's
wanted
gonna be
to
ridiculously easy to write down. It just occurred to me that's probably the honest to God best workaround.
All right, or you can send the images on Skype. You can send it in the chat here, like whatever's gonna work. So what are we trying to do? What do we want to write down?
Well, I was gonna say 3x plus 4 equals minus 30.
Hold on. 3x plus 4.
But then I was thinking I probably shouldn't just randomly invent algebraic expressions because I'm going to end up with fractionalized answers. But I guess it's good to get the practice and whatnot.
Yeah.
So I sort of go back and forth on that. I really wasn't sure where we were going to get to today.
All right, now on the delay, I see x plus 4 equals negative 30.
Okay, cool.
But you want me to change it to 3x plus 4?
I'm just working on screen sharing my thing, so it'll just take me a second to window capture my Paint program, and then we can go ahead. But you can just write it down.
Okay.
Maybe what you could do is just look up an algebraic equation with one variable on Google.
Yeah, isn't there a name for that, like binomial or something?
No. It's an equation, algebraic equation of one variable.
Okay.
There we go. We can just work through this one. Okay, so everybody have a pencil and a paper. I guess that's the thing I should have said that was important to bring, but I thought it was.
Yeah.
I guess I thought it was self-evident, and you did bring it. Okay, sweet.
Yeah, I brought it too.
I have a camera on my paper, but I'm not sure how to share my camera. So.
Oh, don't worry about it. Just write
Cool.
down 3. Okay, I want to actually find one that actually solves to something relatively easy. So,
You're on a Mac?
is that okay?
Oh, sorry, I didn't mean to dox. No, I just thought it's interesting. I have a Mac too, but I'm not on it right now.
I just not a big fan of not
Windows.
Macs. That's really the only way I know how to put it. Like it just, yeah.
Why
Windows
should you make
is-
this like confusing? Like it's like 3 doesn't divide into 26 very well.
That's why I'm trying to figure out one that does, but because I can't multitask, I like literally
20
cannot think of one. Which is why I said don't look one up, and you're just like, is that the binomial expansion? It's like, no, it's not the binomial expansion. One step at a time here. Okay, you guys just talk for a couple minutes, and I'll think of an equation that actually solves to a whole number. Okay. I'm sorry I didn't get that prepared because I just figured it was, pretty good chance it was going to get canceled at the last second.
Oh, well, because of me.
Just because it's I don't want to point fingers. I'm just saying I
Oh,
didn't
no,
want to
you
get all
did a
prepared
good
and then have
strategy.
it be all,
You said, "Let's go right now." That's the way to get me, because I.
That's wonderful to know. All right, let's see here. I'm just trying to
Chat says try 3x plus 4 equals 22.
I saw that too.
oh, aren't they sweet? If this isn't solved to a whole number, my trust in the chat may be irrevocably damaged. All right.
Jen, just use your genius to do it all in your head beforehand.
Here's the thing about genius is you have to know what you need and what
X
you
equals
can get
6,
rid of.
yo.
I'm just joking. Not all prodigies work the same way.
So have you already solved the question?
Which one? Yours? Yours is 26 over 3.
Okay, great. And so nice brain damage there.
Wait, all right, so what's the final expression that we're doing here?
We don't want to
doing
jump
Or-
we don't want to jump to the answer actually.
No, I meant the final expression, as in what you're, because on the screen there's a delay. 3x plus 4 equals 22. Is that what you want us to solve, or do you want to do something else?
What I want to do is don't solve that one. It might be exciting to
Okay.
solve, but I want to show you the method. Okay? So right now we're
Yeah.
learning a method that we can use to solve any equation of one variable. Okay.
Yeah, but what equation are we doing? I just want to make sure.
3x plus 4 equals 22. You're
Okay,
right.
okay.
You're right about that. Yeah.
Okay. thank you.
It's about 30 seconds.
All right,
away,
I'm not gonna autistically screech the answer.
All right. It's all good. Just, shake it out. Shake it out. Who's heard of something called BEDMAS, aka PEMDAS, PEDMAS?
PEMDAS, the order of operations.
Blackity black. There's like 5 different versions of it, but I learned it as BEDMAS.
It sounds very fungible to me.
It's not. It's actually anti-fungible. It's
So I was thinking anti-fungible.
yeah, it's just like that. There's a word for it where AB equals BA. Anyone know in the audience? Commutativity.
Maybe.
It's non-commutative.
Oh yeah.
So non-commutativity is a step away from fungibility, right? We want all these concepts to be very, very intuitive, and otherwise they're no good to us. So, what is the point of BEDMAS?
Is BEDMAS like Canadian or something? Because it's PEMDAS in America.
Well, aren't you sophisticated?
No, it's the opposite. I would say Canada's more
Yeah,
sophisticated.
just as much as possible to look like the word penis, right? That's the real cultural difference between us. Anyway,
Okay.
what's the point of this mnemonic device?
You asking me or Aaron?
What is this? BEDMAS? What is it?
Mhm.
BEDMAS?
Maybe we can let Aaron go first, and then if he can't get it, it can go to you if that's okay.
Sure.
Quick, sweet.
PEMDAS?
If you don't know what it is, that's cool.
I don't know what it is.
Yeah, let's go JD. What is it?
All right. PEMDAS is parentheses, exponents, multiplication and division, which are actually grouped together, and then addition and subtraction, which are also grouped together.
That's the order of things that you're supposed to do, right?
Correct.
Yeah, you're close. It's called order of operations. So when you do order of operations, you're actually generally talking about simplifying an expression. So basically having a random expression, which is something with an equal sign in it, and just like a bunch of x's, like it could be x cubed, x to the power 4, sine x, just all over the place. And BEDMAS, traditionally when it's taught, is to simplify an equation to a particular standard form, which is usually in descending powers of x. So if I had a mess of an equation, I'd be going, x to
You're
the
trying to
fourth,
find all the like terms.
group-like terms, and then ultimately have it in like x to the 5th, 4, 3, 2, 1, whatever.
Yeah, yeah.
You're familiar with this idea, that's
most
what
powerful.
BEDMAS basically is. But you can actually use it backwards to isolate x, because expansion and isolation turn out to be inverse operators. And I figured this out when I was a tutor back in the day. I don't think this is a very well-known technique, so I'm glad to get it.
I don't know if I've heard that before. What is it?
I'll just show you
expansion.
how to go through
Okay.
it's easier if I just show you the method than literally if I try to like meta teach you, it doesn't work. So the first thing you have to ask is x isolated? So it's like a question and answer thing. So here's x. Is it isolated? Aaron.
Is x isolated?
Yeah. So first of all, what's it mean for x to be isolated?
You got to get rid of that 3.
He's
And
got to be
the
on his
4
own. He's got to be the forever rock on one
is on
side
the side.
of the
Yeah.
equal sign, right? So isolated just means x with nothing else.
Yeah.
So the question
true.
is x isolated in our 3x plus 4 equals 22 expression?
No.
And then the answer is, or sorry, the next question is why not?
It's racist.
Well, we want to be explicit. So we've got multiplication by 3, multiplication by 3, and addition by 4.
True.
See what I'm saying?
Yeah.
We've got a times 3 and a plus 4. The question is, which one of those do we deal with first? Answer is BEDMAS backwards.
Oh, okay. Now I
So
see
this is
what
where
you
most
mean.
people get tripped up, having taught this for many years. That
like, I
people
knew
just
what
don't
to
know
do,
where to go.
but-
It's like, do I do the 3 or the 4? And then it's like, give up. Right? So instead of that, what we're going to do is BEDMAS backwards. So if we're doing that, which one would we deal with first?
The
Subtract.
4.
Well,
Subtraction.
there
and
is no subtraction, right? We want to deal with the plus 4.
Yeah, addition.
So plus 4 is there. So we have to inverse. We have to invert the 4. That's how we isolate, is by inverting. So what's the inverse of plus 4?
-4.
There you go. So the inverse is -4. So you can make a note of that. It's good to go over this thought process, write it out. It's a multi-step thought process, but it always works really well. So we found the first inverse operator is -4. And in order for the equation to hold, i.e. we don't want to lose this equals here, we have to do the same thing to both sides. Right? Just like, think of it like having 2 wives, one gets jealous if you don't do the same thing. Possibly a terrible metaphor, but we'll see. So what are we doing? We rewrite the equation, 3x plus 4, but now we add, we put in also a -4, and then equals, and then we put 22 on the other side, and we're going to do the same thing on the other side. So we're just subtracting 4 from both sides. Are you writing this out as well? I can't be there to look over your shoulder, but I'm assuming you have a piece of paper with lines.
Yeah, I'm writing.
You can write it down.
I'm in it.
Great. So don't be shy to write a lot, because the more you write it out now in detail, the firmer the impression will be, and then the more you'll be able to skip steps down the line, because you'll just be so good at understanding what it really is. But if you try to skip steps now, you're just always going to be in that flimsy, unsure, insecure part. So there's a certain learning curve in math where you just sort of have to learn the philosophy of math. And afterwards, it's like, Okay, I can do this. So we're good with that line that we just did?
Yeah.
So what happens that we have this mess? What we want to do is simplify. So we've got 3x plus 4 minus 4. How does that simplify?
3x equals 18.
Good. So I'll just write that out. 3x equals 18. All right, so now we go through the algorithm again. Is x isolated?
No,
Why not?
because the 3 is on it. Yo,
We want to be more specific than that.
the 3 is totally on it. I don't know.
JD, you want to save us here? Why is an x isolated?
Because you're multiplying by 3 to be
Good.
specific.
We have to identify why it's not isolated, because the inverse operator is related to why it's not isolated. So we've got the reason it's not isolated is multiply by 3. What's the inverse operator of 3?
You're divided by 3.
We could do divided by 3, but we want to get in the habit of actually multiplying by the inverse instead of dividing, because you can't divide by 0.
Okay, you multiply it by a third.
Exactly. So it's pretty much the same, and it is the same for everything but 0, right? So we just
Isn't
sort
that
of want
technically called the reciprocal? Because the inverse would be -3.
well, the reciprocal is a type of inverse. So I'm just trying to
Okay.
generalize the notion of what it means to invert something.
Yeah, well, yeah, because he picked up on that, but I was like, wait, what?
This is not strictly speaking the way that this is used. Like, this is my own method that I developed, that I taught people, that I taught, like, because I knew that
Yeah, I think that
I
is-
couldn't get past the whole, like, how do you isolate X without
that is yeah, for more complicated stuff, it probably does come in handy. To
oh god, it
actually
works
break-
so good. I
break
honestly
it
don't
out
know how
like that.
anyone does anything without it. I'm just like, is this
I
like
think it's just probably they're doing it in their head. It's just like they're staring
Calculator.
at it for long. Yeah.
Isn't that horrible? That sounds cruel. All right, so next step, we've multiplied each side by a third, which is nearly the same as dividing by 3. And it's fine if your first intuition on this is dividing by 3. It's just that to go and actually put that algebraically, we have to say multiply by a third. And then we go and simplify again. So what do we get on the left-hand side?
Can we do an example of 0 after this to like?
We
bring
can
that
do an
concept
example
home?
with 0 in it, but division by 0 is not defined. So we can't
Right. Yeah, but
try to
then you,
define something that doesn't
you-
it isn't defined by definition into existence.
but you would like where you would get a multiply by. Never mind. All right, just finish this for.
It's
for
a
Aaron and then-
tautological, but we can go into that. But yeah, let's just finish this one up. So, what's on the left hand side now, Aaron?
It's what does it come out to be?
What does it
X.
simplify to? There you go. So we've got x, and on the right hand side,
6.
great. So we just we took a really, really, really long time to do a relatively simple question that we could have probably banged out. Oh, look, we have someone in the chat actually giving us more difficult questions. So thank you, Physical Lectures. Super glad that you subbed to the channel or tuning back in, or however you found your way here. I'm glad, and I think that was somebody from the Consciousness Conference. So great to have that in common. Yeah, so x
More
equals
like
6.
the unconscious conference.
Oh,
All right.
nah, it's I
Steven
don't
was
know.
complaining that they like kicked the chat off or something.
I couldn't
Um,
bring myself to be upset over it. I was just like, because it's like when I
Okay.
first talked to him, I was like, hadn't really talked too much about this stuff. Like my extent of talking about quantum mind was like my one friend who was into physics and consciousness with me. We were like, party buddies, university
there-
type thing.
I guess the big thing is like, was there any revelations? Like, was there anything like, hey, we tried this experiment and we tried a new experiment with microtubule. We tried to or was it just like going over the thing they've done at their TED Talks a million times?
Not too sure, because the only reason I cited it was so that I could point to someone and say, I'm not the only one saying this. I had
Yeah.
basically no idea what any of it was. And it's like, I'm not going to wade through all this. I'm trying to find a unified model of physics.
The
And I already know
McFadden,
the mind is a
McFadden guy
photon.
is closer, right?
Who's that? Oh, God.
So I was
Isn't he
trying to
great?
watch one of those. It was like, I don't know. I started watching something else instead. I'll go back to it though. He was
No,
on
he's
some
a
guy's
good guy,
podcast.
but I mean, he's no me, obviously. He's
Mhm.
figuring it out. I already knew it, right? So it's not gonna be the same vibe. But yeah, I think they both have their strengths actually, because Hameroff does have the clinical. Like, there's really no substitute for clinical experience. I don't know how much McFadden has. He may have, but like, how much experience do you have in consciousness? You know what I mean?
I guess it's like
were
the
you a
team
monk
up
or-
with Penrose, who's like an uncontested genius.
Yeah, that
in
was
math.
a smart play for sure.
Yeah,
But I guess it was more just like,
he gives it a lot of credibility. I
imagine
think if Hameroff was on his own, people would be like, "What the fuck do you know?" But Penrose is like, "Nah, this guy is onto something. Listen up, B. He's got cred. Penrose has cred."
Well, some people say he doesn't, and I'm like, how
I
are you
mean, I don't know
evaluating
how-
whether people have how is
Didn't he
your
do that
evaluation
proof?
of authority
Didn't he do a
that
really
Hameroff
difficult
comes out
proof?
as not an authority? That's what I want to know. It's like,
I'm just saying in the math world, like he did a very complicated proof. The infinite, it's like the infinite pattern, infinite tiles thing. Like a lot of them are undecidable, but he like found the class that aren't undecidable. Something.
Hameroff did a math proof.
No, Penrose. I'm saying the reason.
I'm sorry,
Penrose
I was
has,
gonna say, like, you lost me hard.
the reason
Okay.
Penrose has all this credibility is he like proved this really fucking hard thing with tiling.
Well, it looks like we have some kind of algebraic pissing contest now going on. Very
did
nice.
really
very
hard-
nice.
he
Never
did- he
change,
did-
guys. Never change.
He did a really hard tiling job at a site, and all the guys were like, "Man, that's a really nice bathroom," and so everyone loves Penrose. I'll be back in like 2 seconds. All right.
Sounds great. Do you want to try a slightly harder one?
Yeah, let's do it. Let's learn some math.
When I get back, I'll be right back.
Yeah, cool. Okay, so you've got one in here with 2 division signs. You can't. Yeah, it's like you got 2 divisions. You got? I can't do one with 2 division signs in it unless you put brackets, because it's like a dangling modifier or whatever. And then we have something from Colin, which is just like, why? Oh, I guess you're trying to actually solve the question. Okay, I see. I don't want to go into fractions yet because I don't want to overwhelm the
Can you hear me
student
okay?
here. Yes,
Okay. Cool.
we're trying to find another equation, but it's turned into a pissing contest in the chat, so I can't. Just really sad.
Yeah.
It's just how it goes.
Well, what is this? This one looks really huge. 2x minus 1 divided by 3 minus x over 3 equals. And is this like a troll?
I don't think so. I think it's just people getting excited. It's fine. I just
Wait, this one looks pretty like not that bad. Or no, is it just breaking down what we just did? 2x minus 1 over 3 minus x over 6 equals 1/2. That looks manageable, I think.
yeah.
Master, I'm
so-
ready for another problem.
Right. So we haven't I haven't really prepared any. Excuse me. So I will just grab one off the internet. I got 7x plus 5. We can all write this out.
Okay, you started the stream has a totally different thing, so I'm assuming that's ancient history.
Yeah, it'll take a little bit to catch up. Yeah, I was trying to write down what the person put, but it didn't make sense. So if you want to put an equation, please make it make sense. You can't have like two divisors in it without brackets.
Yeah, I was like trying to do this equation from a book, and I had to like ask on a form. I was like, wait a second, I think they're wrong. It's like if you're gonna publish a fucking book on algebra, put the right fucking.
It's because
answer.
people don't want to take the time to do it right. You know, they just want to rush through it. It's like that guy that has the really good theory, Thad or whatever. I sent him like 2,500 words of corrections. He doesn't answer me, and now he wants to publish his book without any of the corrections. It's like, oh, I see. You don't want actually anybody to understand your book. I get
Wait,
it.
is he really like that famous that he can just blow off someone who actually took the time? Like,
It's his prerogative, but you know, these delicate geniuses, and no offense, I love the guy, but that's how the delicate geniuses are. I'm sympathetic to that. I'm just like,
or maybe one thing if like Penrose didn't get back to you because he probably gets like a gajillion, like a bunch of shit, but like McFadden, I'm thinking he probably saw your thing. And
I'm
was
not
just like,
talking about
"Oh,
McFadden.
whatever."
I didn't talk to McFadden. I'm talking about somebody called Thad who has a unified field model, possibly, but because I can't understand the fucking thing, I can't validate. I can't be like, this is a unified field model. It's because it's like,
What?
can you explain to me what the hell this is? He has. I guess that's the thing. Like, I can't even do it justice, and I want to be able to do it justice because it's so fucking cool. But it's like,
How do
this
you
is
spell
impervious.
it?
THAD. I think it's Roberts, ROBERTS. But
Visualizing 11 dimensions.
look up the simplest universe. I'm sorry to have a derailing AA run. I hope this is still interesting for you, but I have an equation which is 7x plus 5 equals 2x
Oh, you know what?
9.
You've mentioned this before.
Yeah.
Yeah. Oh God. Yeah. Okay. Now this guy really knows math. Holy shit. Yeah, I took one look at this. Like, I don't even understand what these symbols are.
X equals 4/5.
Well, the point was to go through the method.
All right.
So that you can understand how to solve equations. So
you put the you put your x's on the one side and the numbers on the other side.
perfect. That's called gathering like terms. So if we had a big list here of what the whole algorithm looked like, the first step we'd be doing on that would be to gather like terms. So what happens when, how do we do that? How do we gather like terms?
Well, I would minus the 2 and put that on the other side.
Yeah, so the way we want to express that is that we're going to subtract 2x from both sides.
Oh, I guess I got it wrong. Oh.
So the step 1 is minus 2x. And we always do the same on both sides and subtract 2x from both sides. So where does that leave us?
5x equals minus 14.
There's still a plus 5, right? We want to go one step at a time. We don't want to rush because these equations will get very complicated. And you have to be able to be okay with a huge degree of, you have to be okay with not knowing the answer just from doing it in your head. There's not always going to be a in your head type answer. You just have to, as Duvid would say, resign yourself to the method.
Okay.
And sort of have faith that the method does work. And the more you can cement it in on this level, the less you'll have to worry about it when it actually does get to the point that you can't solve it in your head. So we've got 5x plus 5 equals, and we're subtracting 2x from both sides. So we've got minus 9 on the right-hand side, right?
Yeah.
And you were saying the next step, we want to gather the numbers, the non-variable numbers on the right-hand side. So what does that look like?
Well, you'd have to take the 2x away on that side, right?
Yeah, I forgot to do it, but I have since done it. Yeah, I realized the error of my ways. But yeah, it's fixed now.
Yeah. It's like it's fixing it as we're talking about it. Yep, there it is.
So what's the next stage of the simplification of this? We've got gotten rid of the 2x.
Get that 5 to the other side.
No, we want to put it in specific language. Okay, you want to give it a try, JD, and try to word it
Well,
specifically.
yeah. To word it specifically, you want to put a you want to invert it and put -5 on both sides.
Subtract 5 from both sides.
Yep.
What you said is technically correct. We want to get it as
Or,
close
yeah,
to English as we
yeah.
can. We already speak English.
Yep.
Rather than like, because it's a bit of a you're sort of fusing two ways of thinking, like a more abstract way of thinking and a more, I guess, algorithmic way of thinking. So we're gonna subtract 5
Yeah.
from both sides, even though it seems, totally tedious to keep repeating it so much. We got +5 minus 5 equals -9 minus 5.
I think Aaron's starting to get some recall.
Yeah, that's
Yeah.
it's so funny that people who think the mind is like an electrical signal. It's like you better hope it's not, because like if you got static electrical discharge, you'd be dead. Like you could literally
People do die from getting
static
electrocuted.
electricity.
People die from getting electrocuted. What are you talking about?
Yeah, but do you die from like walking across a carpet?
No, but
'Cause if
neither
your
does
brain
a
is
a hard,
electrical,
a hard
then
drive
yes, it
doesn't
does
get
kill
fried
you.
by a certain tolerance either.
Okay, so what's happening with this equation? How does it simplify? Where are we at now?
5x equals
Equals-
-14.
Good. So final step is x isolated.
Nope.
Colin got it wrong, man.
Okay, so is x isolated? No. Aaron, why isn't x isolated?
Because it has
It's
5. It's multiplied by 5.
Good. So what's the opposite of multiplication by 5?
The the thing.
Starts with a D.
Well, you could divide, but I thought we don't divide. We like
Multiply by one.
the
You can say divide by 5. I'm
Okay.
fine with that. I'm just saying that you need to sort of remember that you can't divide by 0. That's the only thing.
Yes, so for more complicated ones, we'll probably want to do the multiply by 1/5 or whatever.
Not to be super like pedantic here, but I think it's fine to just say, yeah, you can divide both sides by 5 because that's the opposite of multiplication by 5. Alternately, you can say you can multiply both sides by 1/5. That's another good lesson to just get used to, is this idea that dividing by 5 and multiplying by 1/5 is the same. So division and multiplication by 1 over a number is the same.
Let's call it a reciprocal.
Yeah, exactly. So how are we feeling about this stuff now?
good. We can go into the next level,
Okay.
next step.
Are you ready for the next level?
I think I got this like down pat. I'm pretty surprised actually.
Well, I've taught for quite a while. So, it's nice to be able to put my skills to use. So, do we want to go into trig, which is what? Ooh.
Right, so the final answer is -2 4/5, right? Or well, yeah, you can express it a bunch of different ways.
Oh, it's like -14 over 5.
Yeah, I mean, yeah, you could have that as the final.
Yeah, so we have some sign. We can address some sign conventions, right? Like, so this is sort of probably not, to me, not super relevant, but it is, whatever, could be something. So whether you want to write a fraction as what's called, I think, an improper fraction, when the numerator is larger than the denominator, versus what you just said, which was a mixed number, right? It was -14 over 5, right? Is that what it was?
Yeah, -14 over 5, but
so that simplifies to 2 and
2 and 4/5, or as a decimal, -2.8.
Okay, so that's a good thing to mention. Is that these are equivalent. minus 2.8, minus 2 4/5, and minus 14 over 5 are all basically the same. I would tend to go with the first
They're
one.
They're fungible.
They're equivalent. They're not fungible. They're equivalent. So we want to know.
They can be substituted for each other. Isn't that what fungible means?
That was, that was about the philosophy of numbers. Now we're presupping.
Yeah,
that
yeah.
numbers
Well,
are fine.
equivalent.
We're presupping that we accept the fungibility of
equivalent is like fungible and more.
Non-real. I would go with the first one. I'd go with minus 14 over 5 as my preferred notation because it's just less. It's less clunky. Like the mixed number to me is something I haven't seen a mixed number.
And it's already simplified, right? Because 14 over 5 that's as simple. But if it were like 28 over 10, you wouldn't want to leave it like that, right?
Oh yeah, exactly. You want to break down. Maybe we could do that as a prime factorialization before we go into trig. You want to do that? You want to pick a number to prime factorialize, or is that too easy?
For me, I think it would be good to review it. I'll probably pick it up pretty quick, but
all right, let's try one right now. So I'll go with 63. So how do we prime factor 63?
All right, let me write it down. Yeah, I remember doing this with my friend who's like savant. He was showing me stuff. Okay, so
Hey, Aaron, are you paying attention? Because it's 63 with two little lines coming out the bottom. We're doing a prime factorialization or factoring. I'm not sure what the right word is. Breaking a number into a product of primes, yo.
Yeah, I don't know what to do with that.
So we start with finding two numbers that multiply together. Yeah, 63 is, we're going to start with 63, and we want to find two numbers that times together to give you 63.
31
so
and 3
times 21.
I don't think 31 and 3
wait, what the hell?
Because that would be 93.
Yeah, no,
I said 21. 3 times.
This is okay to use a calculator. This is totally fun. Like this part to use a calculator is probably to your advantage. Like you don't want to delegate your thinking to a calculator, but it's okay to do. This isn't delegating your thinking to a calculator to find factors, because the method is to actually break it down, right? Until you get to a prime. So is 3 a prime?
Yes.
So we don't have to go any further than 3. And what about 21?
I don't know if you corrected it already, but Aaron's absolutely right. It's 21. Yeah, okay.
Yay.
Okay.
So then we go to 21. What times what are both whole numbers equals 21?
3 and 7.
Good. So we have succeeded. So it's not particularly difficult to do this.
Yeah, and then you combine the 3's, and the final answer would be 3 squared times 7.
So if you wanted to prime factorialize 63, you have 3 squared 7. Yes? Any questions about that?
No, this one I got.
There's no such thing as a dumb question, honestly. I've heard them all. Truly, it's not a big deal.
No dumb questions.
Today I'm mastering.
Well, the point of it is partially a confidence building exercise. It is possible to get psyched out by math for sure.
Yeah, like when you look at when you look at the Thad Roberts equation.
TFW. You feel like you've had a stroke. The thing is, I really want it to be true because it's oh my God, it's the same cardinality as my system. It's 3 plus 1, right? Yet again, and it's an entangled 3 plus 1 because the basic starting point for constructing the knot is
what is he?
What is it? A polygon with 4 sides, whatever that's called. Sorry.
He's got a P0 equals factorial factorial n. Wait, what does the exclamation point before a number mean? That's not the same as factorial, is it?
I know he
'Cause
was using factorials in his notation,
Yeah,
but
wouldn't that be n n and then the exclamation point? Or do I have that wrong? I'm sorry, I'm totally derailing. All right, so we're doing
like for something like that, just make a note of it, and we'll come back to it later because like I have no idea what algebraic expression you're really talking about. Okay, so there is someone in the chat
Yeah.
asking about me to solve an impossible equation, which was, let's see, it was something that was a contradiction. 2x minus 4 equals 2x. I don't know if we want to try to do that one or
It's
what.
one of those like trick ones on YouTube where it can have like different answers.
2x minus 4 equals 2x. So we could maybe talk about why that is not. I think it's called degenerate.
It's degenerate.
That might be something else, though. I have to check. But basically, this has no solutions because it's equivalent to saying that minus 4 equals 0.
Yeah, right. Yeah, it's a the expression is not true, so you could never solve it. That's basically what it comes down to, right? If
Pretty
you
much.
Yeah, if you have an untrue expression, you can move all the shit around forever, and it'll. Is that what you're writing out, or
it sort of starts to? Well, I just wrote the equation down. I don't know how much I want to actually like solve it. Like we'd be subtracting 2x from both sides, and upon subtracting 2x from both sides, we would be resulting with minus 4 equals 0.
Yeah, right.
Which is impossible. So there are no solutions. Algebraically, we would express this as there's no solutions to this. Right. So if these things both represent lines, it's basically saying that the lines don't intersect.
That equation like perfectly represents the conflict between the Arabs and the Jews.
Which one is the Jews and which one is the Arabs?
The Arabs, I don't know.
The Arabs are the 0 and the Jews are the -4. Because we like to complicate things.
Are there questions about why this would be either called inadmissible or degenerate or whatever?
Inadmissible?
Are we cool with why 2x minus 4 can't equal 2x?
Yeah.
There are more proofs, right? Like I could go into an algebraic proof, right? Because it's basically a question of where do two parallel lines intersect? Well, nowhere, right? Unless they're the same line. But that's definitional. If you have two parallel lines and when the slope is the same, that's the criterion for being parallel, i.e. 2x minus 4 equals 2x. Well, the slope there would be 2, right? Two straight lines with same slope, which intersect the y-axis in different places, never intersect each other, right? Next.
Parallel lines don't meet.
Yeah, exactly. So is that, or is there, if there's anything else in that, I can come back to that example when we actually get into algebra, but we're still not past trig yet. So algebra is...
You mean calculus?
Well, it's more algebra to do calculus. But Aaron, when I say algebra, what do you think about?
X equals something.
Yeah, as in like it's defined on an infinite line. So there's a jump in complexity when you go from a finite thing, which is just like a triangle, to an infinite thing, which is like the real number line, where you can plot various things that go on forever, like the line y equals x. It has, value of y for every value of x, and it has infinity many values, right? Whereas a triangle has 3 finite lengths. But so are you familiar at all with trigonometry, Aaron?
I mean, I was, but I don't know what I remember, what I don't.
All right, so if you've both got your pencils,
static electricity.
We'll go over the basics of trigonometry. So eventually what we're going to do is take what we learn in trigonometry and generalize it to the real number line, which is where it gets really powerful because you're going to talk about like signals, repeating patterns, and that's where it gets more potent for replicating reality, right?
Is like the unit square involved there?
Exactly. If we inscribe a triangle in the unit square and we just have the hypotenuse basically rotate the projection, like the projection of y equals sine x onto the unit sphere is that rotating hypotenuse.
I believe you, but I
I don't know if that was
visualize
probably
it.
way too obtuse. I'm sorry, but yeah, there is a
I can't visualize
it's
it.
not
like,
a
so-
bijection, but there's a connection between the projection onto the unit sphere and the generalization to the infinite number line.
Let's
like
just
you-
start with the triangle that you
Yeah, we'll
drew.
start with a triangle. So what is the basic premise behind trigonometry is relations between the lengths and angles in a triangle. So if you guys can both see what I have up here, it's just like a generic right angle triangle. And I've labeled one of the angles. Does
that didn't
anybody
come
know
up
what?
yet.
Okay, so I've labeled it with a Greek letter, which is the standard Greek letter that they use for these kinds of things. So
Or something.
there's one little square in the bottom left of the triangle,
Mhm.
and for those of you who aren't familiar with that, that means it's a right angle, so 90 degrees, or I guess pi over 2.
Oh, is that theta? Is that what that symbol is?
Yeah, theta's like your most generic.
I tried to study the
Greek
Greek
letter.
alphabet, but then I stopped practicing. I do remember that one.
Right. So what would we do if we were treating this object? We want to label all the lengths. So your standard is
Yeah.
to have ABC with C on the hypotenuse.
And a little square means it's 90 degrees, right?
Right. So we can define one
Control my
relation.
version.
We can already define one relation between these variables. Does anyone know what it is?
We can define one relation between.
But they
the-
have to add up to 180, right?
Oh well,
Yeah.
A, B, and C aren't angles; they're the length of the triangle.
I didn't see that yet. I didn't know if you were talking about the angles or the sides. The sides is the it's the it's the Pythagorean theorem. A squared plus B squared equals C squared.
Cool. Do you remember that, Aaron?
Yeah, I was going to say that.
So we already have a predefined relation.
I don't believe you. Stop cheating
Predefined
off me.
relation. And we may not have to use it. We may use it, but actually I'm pretty sure that this relation is how you get the sine law and the cosine law. So trigonometry is all derivative of right angle triangles, but then you
Mhm.
can generalize to non-right angle triangles in two formats called the sine law and the cosine law.
Okay.
So what is the sine of theta?
Where's this? Theta?
Oh, what, like, is it if it's tangent or cosine or whatever?
Yeah, I'm just throwing you a curveball to see if anybody knows what sine theta is, or I can just give you the answer and we can.
Just get the answer.
There's a mnemonic device, so I'll write it out. It's
Oh, yeah.
SOHCAHTOA.
So, yeah.
So SOHCAH
Wait, hold on. Let me write that down.
TOA. All right. It kind of reminds me of Pocahontas. But yeah, this is your mnemonic device for this simple little right angle triangle. And it's telling you, so everything in trig is a ratio. So it's one thing divided by another. So the sine of an angle is the opposite length divided by the hypotenuse. Now, do you know what the hypotenuse is, Aaron?
Do I know what a hypotenuse is?
Hypotenuse. It's
No.
okay if you don't know.
No,
It's
no.
the line opposite the right angle. Oh, I'm sorry. I should have given a chance to JD to answer. I'm sorry. I got too excited there.
He
I'm
gets
sure
all
you
the
knew that one. Well, I think it's about 50-50. All right. So what would the sine of theta be?
It's the one labeled C.
That's the hypotenuse, but sine
Mhm.
is the opposite over the hypotenuse.
Okay, so all right, I'm trying to understand how to map that out. Sine is the opposite over the hypotenuse.
The important thing to remember with this is that it's relative. So the sine of theta is relative only to theta. So it's which line is opposite theta in that triangle.
What sine is opposite theta?
Which line? Because there's only 3 lines, right? There's the triangle has 3 lines,
Okay, yeah, okay.
hypotenuse,
So
and 2
wait,
others.
hold on. So the theta is opposite, or it's pointing at A, right?
Well, the way to do it is you pretend you're theta.
Yeah, that's what I'm saying. If I were theta and looking
sine.
out, I would see the side A.
And yeah, and to find the sine of theta, it's the opposite over the hypotenuse. So what's opposite theta?
Which angle is opposite, or
No,
which
length.
side?
It's the side length. It's not the angle. The sine is the angle is on the side of the sine. So sine of an angle is a length over another length. It's the opposite length over the hypotenuse length, not an angle.
So A over C?
Yeah. So sine
Okay, all right,
is
hold
really
on.
simple. That's all it is.
It's the terminology that
You don't want to overcomplicate this stuff because it does pick up in complexity. Like once you get on a unit sphere, infinity line, it's like, yeah. But this level of it isn't super hard. But it seems
Right.
it snowballs quickly once you start
Yeah,
having
no,
to invoke these.
I've done this before. It's just I'm trying to remember the okay, so because what SOHCAHTOA means, so SOH means that the sine of theta equals opposite over hypotenuse, which will be A over C, and then you actually have to reverse, because that sine is actually, you would put parentheses around theta. It's the sine of theta equals A over C, and then so you have to do the opposite of the sine operation on A over C.
Yeah, exactly. So you can see that the approach I taught earlier applies generally to everything. And if you want, like for your own enjoyment, quote unquote, try a really complicated one. Just see how easy it is. So what JD's talking about here is that we can invert the sine operator with what's called arc sine, I think. But if you're doing it on a calculator, it looks like sine to the -1. So sine inverse, arc sine, sine to the -1. That's all the same thing. It's the same idea as the inverse operator that we talked about earlier. But you got to be careful with inverse operators. You always have to remember that you can't divide by 0. So there may be regions where it's not defined. It's very appealing as a method, but you want to be careful, like not accidentally get in a situation of 2x equals 2x plus 4, right?
Right. Yeah. The untrue expressions.
Well, just accidentally, doing a non-allowable sort of operation, and then it's hard to.
Yeah. What did you? I like
track
that
back.
term you said, inadmissible. It's like, I think the reason I was laughing is like, because it's like as if you were like bringing a math equation to the courtroom. And the judge is like, no, it's inadmissible, bro. Okay, so
we figured out sine. So what's cosine theta?
Wait, hold on. Just real quick though. So you're saying that the opposite of the sine operation can be noted as sine to the -1 of whatever?
I think that's normally how you'd be putting it into a calculator.
Okay, yeah. So like on a TI-83, is it gonna have like a button that says sine -1?
It might be arc sine that they use.
Arc sine. What does that look like?
ARCSIN. I'm really not sure, but you can just Google that. Just put sine inverse on a blah 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 calculator, and it'll tell you. I'm used to seeing it as to the power of -1.
Sine inverse trigonometric functions.
That's a little bit more complicated, so we will get to that, but let's just bang through these. So
Well, yeah, no,
Aaron-
I'm looking for the notation. Yeah, okay, right, okay. So they have it written that you can note it as the -1 of whatever thing. Okay, and then yeah, typically the function might be named arcsine. What about, is it the same for all of them? Just like arc whatever? Yeah, arc.
yeah, they weren't
cos,
particularly
arctan.
original.
Oh, it's not about being original.
I'm
It's
just
like
kidding.
it's a suffix.
Yeah, I guess that's what they chose for the inverter for trig.
Well,
It's
yeah, and
ARC.
it's better because on the computer you can have a function that's just named that. Whereas, you know, what are you gonna name? You're gonna name your function tan caret -1. I don't even think that's allowed in a lot of languages. So it's better when if you're ultimately aiming to put this shit into a computer, you know, having functions that you can actually spell out is good. But all right, sorry.
Okay,
Didn't mean
so
to derail.
Aaron, did you write down the mnemonic device SOHCAHTOA on your paper?
Yeah.
So that stands for sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent.
This Fiska lectures is like typing the exact thing I just said. It's weird.
Oh, it's nice to have supporters.
Mind meld.
And
I think he was typing it
serious
as
people.
as I was saying it.
Well, you know,
All
quantum mechanics, like locality is an illusion, man.
Yeah.
So, Aaron, what is the cosine of theta? You want to take a crack?
What is the cosine of theta?
Mhm.
I don't know. I don't even know what you're talking about.
Well, wait. Let me see if I can get him there, like step by step.
Awesome,
So,
thank you.
all right. So, would you know to go to the middle one to get that answer? Because the middle one is the S. You know, in SOHCAHTOA, that it's like, what do you want? You want the cosine, so you go to that. You go to that one. So it's CAH.
Adjacent to hypotenuse?
Right. But then how does that actually translate? So you see what we did on the other one. You're gonna put the adjacent. Like, what would you write out?
Now I don't even know what the hypotenuse, like what is H again? And what is
The
opposite, adjacent?
opposite. It is
and
the line opposite the right angle. Remember the Pythagorean theorem?
Okay.
Do you remember what that is? The Pythagorean theorem?
Yeah, we just said what it was.
It's the
A squared plus 2b squared equals c squared.
exactly. So the hypotenuse is C. It's the one that stands alone in the Pythagorean theorem.
Okay.
And it's only ever a hypotenuse when it's a right angle triangle.
Yes,
It's
C
definitely
is
something-
opposite. It's the opposite
Yeah.
of the actual right angle.
Exactly.
The little square. You see that?
So that's the hypotenuse is C.
Yeah, and like, Jen, why don't you draw like another triangle to demonstrate that?
What am I
Like-
demonstrating exactly? I just drew a little
Well, I mean, like,
line in it.
if you drew a triangle, but like, draw it from a different angle so that he can see that it's always the opposite of the right angle.
Sure.
I mean, it's going to be a delay.
What's the cosine of theta, though? Want to try to get that first? Cosine of theta? Anybody?
I have it,
It's
but
the-
Yeah, give it a
hypotenuse.
try, Aaron. I mean, it's not meant to be difficult. It's just a new sort of language. That's all.
Yeah, I don't know what the adjacent would be. What do
So-
they mean by Adjacent, like
Adjacent means it's always relative to the angle we're talking about. And this is the most crucial part about trigonometry, is that we're asking about cosine of theta, so we have to go and find theta in the triangle. So relative to the shape of the triangle, where is theta? Bottom.
Jen, you remember we're on a delay. Like, do you have?
Well,
what we
this
see?
is. I mean, it's been on the screen for a while. The triangle that we started.
Right
It's the triangle that we
now-
started with.
Yeah. Right now we see the blue line, HYP, and then you started drawing the other one.
Is the drawing of the other one done yet?
I don't know if it's done, but it's there. You didn't label anything other than the theta.
Okay, so now there's two. You asked me to draw a second triangle, so there's two triangles on
Yeah.
it now. But let's ignore the second triangle for now. Okay, I'm sorry if this is confusing, but we're ignoring the second triangle. We're just looking at the first large triangle. Where in that triangle is theta? Aaron, can you see it?
and where is theta?
So there's four. There's like, let's say there's 5 possible answers. It could be at the top right, top left, bottom right, bottom left, or middle. Now, which one of those is the most accurate description of where the angle theta is?
I really can't help. I don't
Okay,
know.
so theta
It's
is
that
in the
Greek
bottom.
letter.
Go ahead.
I
Go
think,
ahead
I
and
think,
take
you, I
over if you
think
want to.
we're confusing them. Well, let's.
In the
Well,
bottom
we-
right, there's something that looks like a 0 with a line through it. Okay, that's theta.
Okay.
Can you see it? It's inside the triangle.
Okay.
So the triangle has a square inside it. Do you know what that means?
Triangle has a square inside it. Yeah, that's 90 degrees.
And where is that?
That's where is it?
It's in the
Like, where does
bottom
it-
left.
Yeah.
Bottom
Okay.
left. Yeah. So you just want to learn how to be precise, but not crazy precise, but not imprecise. We want to have that good balance. So we've got a right angle in the bottom left, and we have another angle that's been labeled in the bottom right of the triangle, and that's theta. So when we're talking about the sine, cosine, tangent, it's all relative to that. Basically, you're in the reference frame of that angle. So when we're asking for a cosine, it's the adjacent line to that angle over the hypotenuse. So what line is adjacent to theta?
A? No. B? No,
Yeah.
I don't know.
It's
I
B.
don't. Huh? C.
Fine.
is
No,
most-
it's B. It's B. You had it. It can't be C because C is always the hypotenuse.
Yeah, that's why I wanted you to draw the other triangle so that you could know that like that's always the hypotenuse, and then the terms are the things that aren't that, the other terms. So on that other triangle, do you know which one would be the hypotenuse?
I should
I get-
probably
label them.
with
Yeah.
letters. It's going to be tough, so I'll just go.
Yeah, and don't use the standard letters. Just like use like X, Y, and Z or something.
Well, I can actually get letters. So, like, can you guys see these letters? Well, it might take a little while, but
I don't know what you mean.
I'm adding letters to it. X, Y.
All right, right now we're seeing a cosine of theta equals B over C, and then nothing's happening now.
How's this delayed 30-second delay treating everybody? I kind of like it. This is like way easier than tutoring.
I wish you would
IRL.
pull up the stream so you could see what like you're waiting for me to describe what's on the screen.
I would love to. Having tried
You're-
it, I know
yeah,
it will
you think it's
totally
gonna,
F
like,
my
echo?
computer. Well, my
Yeah.
computer has like limited, it's
We have like an old Dell or something. Oh no,
Well,
you're on
this
a
is-
MacBook.
it's just not able to do
20
certain things.
2011 MacBook that still has a CD drive, I bet.
You know me so well. So have the new algebraic variables appeared yet?
Yeah, I think we're seeing the X. That's weird. You happen to do what I thought. Oh yeah, so you labeled it X, Y, and Z.
So I forget what that little fish-looking angle is there. I just randomly drew a shape.
Oh, I thought you were trying to make a theta. I was like, what the fuck?
I was trying to do a letter that wasn't theta because I don't. It's sort of bad form to keep using
Right.
theta.
Yeah. Especially because they're on the same screen.
So we can call it the angle fish because it kind of looks like a fish. So what's first of all, can you see the triangle, Aaron, with the XYZ on it?
Aaron.
I can see a triangle. Yeah.
Small one.
X, Y, Z. Yeah.
Which one's hypotenuse?
X.
Good. So that's actually just order of operations wise, probably good to actually identify the hypotenuse as the first step. Now that I think about it. What is the sign of fish? What do we do here? Big silence.
Opposite over hypotenuse.
Good. So relative to that angle, what's the opposite line?
So Z over. What's the hypotenuse again?
You said it yourself, remember?
Yeah.
All right, so I'll just write out what he's saying here,
X.
and I'll. Good.
Yep, you said it. Yeah.
And what about tan fish?
Opposite over adjacent. Z over Y.
Is that all right? Yeah, perfect. You got it. So it seems like you're getting it. What about you?
Yeah. No, I was shutting up because I didn't want to, yell out the answer.
But just so I'm clear, you're okay to this point, but to generalize to unit circle projection to infinity, that's where it's not 100%.
I don't even I was listening and I believe you, but I don't I can't visualize it. So
yeah, that's cool. I mean, that's a perfect place to be, basically, like rusty but aware of. Yeah, we'll have lots of fun.
This I did I did an actual applied physics class with this kind of stuff, and we did optics and stuff, and we figured out what the ideal angles and stuff to multiply, and we did stuff with bullet trajectories and all that kind of shit. So I actually there was a point where I was proficient in what we're doing right now, meaning I could just look at it and be instantly okay, I have to do arctan of this, and then I plug that in here, and then I do whatever to.
So did you like my algorithm?
Compensate for wind and all that shit.
Did you like my algorithm that I came up with?
What algorithm? The PEMDAS algorithm?
Yeah, the opposite of PEMDAS, I guess.
Yeah, to when you're simplifying to yeah, and I also like the concept of multiplying by a reciprocal. It's a good way to visualize things.
Thanks.
I had this
can I erase this?
Who was the opposite. They were like, "What? Well, you have to cross multiply." And I'm like, "Yeah, but that doesn't help understand it. That's just a way to do it faster."
The teacher probably honestly didn't understand. I mean, not to judge his personality.
Yeah, no, she was an idiot.
I went to see a Cal professor with a friend of mine who was having trouble in the class. They didn't understand why, when it's a definite integral, the constant of integration disappears.
We're not. I don't know what that stuff is yet. This is where we are.
But the point is that the prof couldn't explain that. It's one of the literally easiest things in calculus as to why, for a definite integral, the constant of integration disappears, because you're subtracting one from the other, and they both have the same constant, right? It's so easy.
They couldn't explain it.
The point is, the prof was like, "Isn't it obvious?" He just kept getting so triggered. It's dude.
Yeah, there's certain. It's people have the wrong personality to be a teacher. They're they just want to be smarter than everyone, and so especially sometimes an advanced placement course or whatever, they're expecting the kids who come in to already know it. So it's they're not really there to teach. They're there to really they're there to like test them, if that makes any sense.
Socratize them down to a babbling mess. That reminds me, the images I sent you, Aaron, you should definitely print those all out by next time.
Okay.
You
I was
got
looking
those?
for them. Okay.
If you need
What
me to
image?
resend them, I can. But yeah, they're good to have because they're just like the basically photocopies of what I had in my own textbook, which I can follow from, which is a great calculus textbook. But in there, I think you'll find the special triangles. So there's
Special.
there's like a triangle that is 1, 1, and root 2 on the hypotenuse. So that's like the triangle that has 45 degrees and 90 degrees.
Do I need this picture too, or not?
Yeah, I'll get all that stuff to you. It's just like, I mean, you can print it out if you want. I want Aaron to have it just so I can make sure that I can like see what's displayed on the screen right now.
Yeah.
Is that possible? Because if you've got it all copied down, I'll go over one last thing and then we can wrap it up because I think we've had a pretty successful, productive time. But I did want to get to one last thing before we're done. But can I erase this now? We're all
Go
cool
ahead.
with everything. Sweet. So who knows what the cast rule is from Trig?
Cast
I'm
rule?
gonna guess that that's no one. Remember how I said the XY axis is super important?
Sure.
I wasn't joking. So I've got a new thing displayed here. I'm adding some details, so it might take a couple minutes before it finally shows up, but
All right,
we're
it just
back
blanked
to
out. Okay, there's a
we're back to the
line.
familiar axes. Okay.
Yep.
So what do we tend to label the horizontal axis?
Y? No, X.
Are you familiar with this, Ron?
Negative.
Okay, so sign convention time, the horizontal one is usually given an X, so sometimes it's T, but we'll stick with just X and Y because we're just in the pure geometry now. T is usually when you go into physics type applications. So X is horizontal, Y is vertical. Cool with that?
Mm-hmm.
Okay.
Now I'm used to the quadrants being labeled like 1, 2, 3, 4.
So what's 1? A?
1 is the top. Yeah, it would be like A would be 1, S would be 2, T would
I'll
be
throw
3.
those on also. Like, it's definitely a worthwhile exercise to go through on your own and
This is probably better.
remake these diagrams yourself because it really helps to cement the ideas. And it's just so nice to be able to access them. And it actually, I think it really does help you speak better because it helps you be more precise, like when you're used to referencing things that precisely in a mathematical sense. So yeah, this is another way to look at it. We've got 1, 2, 3, 4 and rotating counterclockwise, starting at the x-axis. So Y, that's another sign convention. So this is the positive x-axis here, and then this is the positive y-axis here. So we tend to start rotations from the positive x-axis and go like this.
All right, now these letter labels, are they just letters or do they stand for something?
I'm about to get to what they stand for. It's another mnemonic device. What I did is draw basically like theta growing. So theta starts at 0 and then just increases. And it'll keep going. It doesn't go on. I mean, I can't draw it forever, but obviously you can see what I've got there represents a growing angle. So we want to know is solving for...
Is that supposed to be like a perfect spiral?
No, it's... Well, I mean, all it was meant to be was to show an angle increasing continuously. Because the angle, the angles aren't restricted to 0 to 2 pi, right? Like they're...
Well, like, is it
defined on the
following
entire...
the golden ratio, or is it just like it just doesn't matter? Like,
if you imagine, like, what is X doing when you're doing X versus Y, right? Like X is just monotonously increasing. Is it not? It's the same with the angle here. It's just like counting. It's just that when you're counting an angle, it's counting in a spiral versus a line. So it's,
yeah, well,
it's
now,
not.
you're making like you're making a triangle now.
I'm showing you the bow tie rule, aka the cast rule.
Okay, so in my notes, should I draw a spiral or should I draw the bow tie?
Don't draw the spiral. I am sorry for drawing
Oh.
the spiral. I should have
Okay.
mentioned not to draw the spiral. All right.
Yeah,
I'm
'cause
gonna have
now
to draw a
like,
theta here.
I'm like, oh, the golden ratio? Hello.
I'm sorry. You thought it was going to become like the movie Pi there for a second. Okay, so the whole point for this digression
Yeah, we're
here.
gonna solve the stock market.
I definitely loved that movie when I saw it.
That's a great movie.
Isn't it the same guy who did the music for Requiem for a Dream?
You mean directed?
Oh, maybe it is that.
I think it has the same
director. I
music.
thought it was the
It might
same.
be the same music person also, but I know it's the same director. He's one of my favorite directors.
Yes, I want to say Aronofsky.
Yeah, that's right.
Is that right? So here's your bow tie rule. Back to sanity here, but here's the bow tie rule. And what do we have here? We're talking about like solving for angles. So
Is that the null symbol or what the hell
It's
is
a
that symbol
theta.
called?
Theta.
Oh, it's a capital theta though, right?
It's just regular theta. I just drew it in a way that I thought would be easier to to see because I thought my last theta was somewhat not clear. So yeah, it's still theta. It's still designating an angle. So the important thing is that the absolute value of sine, cosine, tangent of these angles are the same.
Okay, so these are all equivalent angles.
So if not equivalent, but the absolute values are equivalent. So
Yeah, because the some are negative, right?
yeah, so the point is that the cast rule shows you how to figure out which are negative and positive because it basically tells you that A is saying that in the first quadrant, all of the ratios are positive. Sine, cosine, tangent. In the second quadrant, it's telling you that sine is positive. In the third, it's telling you that tan is positive. And the fourth, cosine. So by inference, the ones that aren't mentioned are the ones that are negative.
Okay, so the point of this, the cast rule, is to tell you which one is going to be positive. So in quadrant 1, the adjacent, it's the adjacent that is going to, wait. I'm confused. What does A stand for?
All.
Oh, okay. So in the first quadrant, all angles are positive. In the second quadrant, only the sine is positive.
Mm-hmm.
And in the third quadrant, only tan is positive. And in the fourth quadrant, only cosine is positive.
Perfect. You're following along with that, Aaron? I know it's probably a bit much, but we'll have examples you can go through and try.
Yeah, sort of.
So what is this basically telling us is that if the sine, so let's say we take theta is 30, sine 30 is equal to sine of 180 minus 30. Because each of these is measured relative to the positive x-axis. So each one is sort of going all the way. But you can... Those are the absolute angles. We don't want to draw those absolute angles in. I just drew a bunch of like light blue angles and you don't draw those in, but that's the basic idea. And we're trying to figure out, basically there'll be 2 solutions for every one. Because there'll be 2 quadrants where it's negative and 2 quadrants where it's positive for every solution. Does that make sense?
Hold on, I'm still writing all this shit down. I wrote down the rule with the all, sine, tan, and cosine.
We'll go through some examples next time, and now that I know where everyone's at, I'll be able to find examples that are actually like at this level where we can go through this rule and see, and it'll be obvious.
I
don't think it's very obvious now, but I just wanted to sort of give this as a basic primer. that
All right, I'll write down theta equals 30. Is that a number or is that a you wrote theta equals 30, sine 30 equals sine 180 minus 30?
yeah, I'm trying to illustrate what the graph is actually saying. So the idea is that the sine of 30 and the sine of, so this is 180 and minus 30. So the bow tie is 180 minus 30. I realize it's probably not very clear because you can't see things as I'm writing them. But we can go into this a little deeper next time. Like, I'm sort of unprepared to do a super deep lesson on this right now. And I know that we need some examples.
Maybe next time we'll figure out a way where you can also show us live. Like, so you just jump right in and then it'll just be confusing for people in the chat. Or, well, ultimately they'll see it all together, but if they're trying to interact,
if I think the best plan is to probably have some questions ready to go before we start, and then we'll go, and then we'll already know what the question looks like. So you'll be like 30 seconds behind on a question you already probably have written out, rather than just me trying to sort of dig this stuff up from back in the day. I think I'm doing okay. A little rusty. What do you guys think?
Yeah, I think
You kicked ass.
Yay!
Yep. Yeah, this is the trig stuff, and then we're venturing into the stuff we didn't go over, which is the unit circle. I don't think I ever saw the bow tie thing.
Well, the key to being good at calculus is algebra. It's very much I don't know what you want to call it, but it's basics, like the little Legos, you know, putting the Legos
I've
together.
heard calculus it's like introducing time to everything, right?
Calculus is
there's a bunch of ways to look at it.
The calculus implicitly axiomatizes linear algebra. So everything that is a convention of linear algebra is also a convention of calculus. And then there's this additional thing in calculus, which is the definition of a limit. The limit of, like, the slope is. What's the limit of a slope? Well, it's the derivative. And that's basically imposing an additional axiom that it is indeed possible to find this type of limit point, i.e. the differential. So we have this extra sort of, I call it an axiom because that's what it is, a condition, a postulate. You can call it what you want, but it does boil down to essentially an axiom.
I'm sure it'll make more sense when you draw it out.
I'll just show a little picture here before we say goodbye.
I think I'm gonna have to do some homework before
Yeah. Why don't you give us homework?
I will. I'll now that I know where you're at, I'll find something and I'll give it to you. It's I didn't want to give anything before we actually had a chat because I didn't want anybody to get discouraged. But how are we feeling? Are we feeling like it might be fun to keep going?
I'm following so far.
What do you think, Ron? You want to keep going and do more streams like this? I'm having so much fun, honestly. This is right up my alley. Like, I like this more
is
than
what I originally
wrecking all those people on those debates. Like, not that I don't enjoy the odd debate, but this is more fun for me because I know that the chances someone gets something positive out of this are pretty darn good.
Yep.
Chances somebody gets something positive from a debate ass whooping, well, maybe not as positive, is it?
I think just establishing all this and having a group of people that have these math skills and are following what you're talking about, we can then venture into. It's like you have a lot more to stand on, because then if someone's like, "Oh, well, how do you know any of this?" then we could talk about all the details.
We all know on some level the Socratics will never be satisfied because they're attached to their midwit LARP. So It's going to involve
I
the
still don't even.
inverse
I still,
transform function of Socratism, if you will.
I still don't fully understand your criticism of the Socratic. Like, first of all, I need like a solid example of the Socratic. Like, like what are you saying when you say that someone is using the Socratic method? Like, because the scientific method I like, and doesn't that come out of the Socratic method, or
No.
am I okay? Okay, so
No. A
just
steaming pile of wreckage comes out of the Socratic method. A dead
all
guy.
right. Well,
comes out of
okay,
the Socratic
but here
method.
let's start with this though. What would someone who likes the Socratic method like? What would they say? What would they be like? This is great because I can, because it does this.
Let's look at the alternative, right? What's the alternative? Is Socratic method is just the disciplic tradition. The disciplic
Like
tradition is
disciples.
extremely difficult because you have to humble yourself. Like first you have to spend time finding someone to be the disciple of, right?
Mhm.
And you have to be responsible, right? If this person turns out to be a crackpot, that's on
Mhm.
you.
Right.
And so you may have to, spend a long time gaining the favor of a teacher that turns out to be a disappointment.
Okay.
So when you're having a traditional Gurukul system, which is what Pythagoras tried to do, there's a presupposition of the guy running the fucking thing actually knowing fuck all, right?
Yes.
So there's a dishonoring to that. My point is that Socratic method didn't arise in a vacuum. There must have been some problems with the established authority in Athens that made it weak to this type of subversion. Because if they actually were running a tight ship, somebody like Socrates never would have been anything. And it's possible that he wasn't anything, and it's just all retro engineered to justify the Socratic method from the vantage of the, what does do we call it? Reverse
can I take
engineering the past or something?
retro?
I forget what it is.
It's like retro.
Anachronizing.
Yeah, and isn't there another name? It's like you're retroactively it's like the winner writes the book. All right, well,
I hadn't finished my explanation as to what the problem is with the Socratic method. It's not a black and white thing because it's quite good for what it does.
well, yeah, that's what I was trying to figure out is like, the people who swear by it or whatever, like what are they trying to do? What are
they
it's like-
are enjoying the illusion that they have the right to speak. Because
okay.
that's what the Socratic method does. It gives you the delusion that your questions are worth hearing. And
Didn't you say there's no stupid questions?
I did, but if somebody is going to ask me questions in bad faith, which if you're just
right,
if you're listening to what someone's saying only because you're hunting for logical inconsistencies,
yeah, that's annoying.
You're in bad faith to some
Okay,
extent.
yeah, I don't like bad faith arguments.
But the thing is that the Socratic method is great when there's an established knowledge differential. Like for teaching, it's great. I mean, I'm pretty sure it's been used on this very stream. Like whenever I ask for strategic questions, you could argue that's the Socratic method. Because I'm teaching you something. It's a very precise way to teach things.
It's kind of like you're like sort of asking like probing questions. Would that be?
Well, I undo my ignorance of your mind state through a series of strategic, particular penetrating questions to get to a point where we're looking at the same thing. And then I can build it back up through a series of, metaphors and examples, you being essentially having the same little bit of knowledge as I have, right?
So asking probing questions, you might say.
That's not what the Socratic method is. That's part of it.
Okay.
The Socratic method has become in the modern day like a full-on philosophy. it's a full-on lifestyle. It's like I don't have to do anything.
It's a
Like just
lifestyle.
watch my tea jump debate. Watch my tea jump debate. Did you see it?
Yeah, and I could tell he was like doing something, but
That's what he was doing. So here's why it can be great in the case of a calculus class, and I think it is. And I don't know. I think it was very productive. Honestly, great. Couldn't have gone better in my view. Why did it fail with T jump and succeed here? Like
because he wasn't actually trying to learn your theory. He was trying to
exactly
disprove it.
is the Socratic method about learning, and can you disprove something you don't understand? Obviously not. It's
Well, yeah, but you were
saying
entering a
you
debate,
can't.
he wasn't entering your classroom, right?
Well, the point is that there shouldn't have been a Socratic Inquisition unless there was a point made.
He should have bothered being familiar with your theory. Yeah, it's like with the flat Earth thing, he's familiar with that stuff, and so there's a reason for it. But I highly doubt. Like he seemed to not even be familiar with your work, right? So is that your point? Is like he's
so damn sure that he's right and I'm wrong because
but like, does he even have any?
Does he believe my sky daddy's stupid? It's like
he didn't. Well, hold on. He didn't even mention integrated information theory, which is really the thing that goes against what you're saying. Correct?
How does that go against what I'm saying? I think I've used an argument to.
Because integrated information theory is basically that consciousness can exist from it can arise from a classical process. The sum is greater than the parts, basically. That you have
the sum being greater than the parts in a classical process. Pick one. Sum greater than parts is a quantum process.
Well, okay, you're saying that, but
that's definitional, right? Classical mechanics is based on particles, which, mind you, don't exist, have never existed, will never exist.
You get what I'm saying? When I say classical, think classical computer. Like I know I don't.
It actually doesn't always mean the same thing. Classical. It could mean because it's like where does something like Maxwell's equations fit in?
Well, just like logic gates, right? Like the abstraction, like programming languages. Yeah, okay. Could you ever get an electrical computer to work? But you know what? You could picture a computer that operates off of pressure, right? And your logic gates are set up that way. And so, just imagining that the computer is a smaller version of that.
How the fuck did we get on this conversation? We're talking
because we were talking about how T Jump didn't understand your theory, and he didn't even really. He wasn't even like talking about an alternative to it. Instead, he was like attacking it from the vantage point of God doesn't exist, and it's like, well, what is that really?
It's like you can't debunk Pramanas. They're undebunkable.
Yeah, right? Like it would be like trying to debunk relativity by saying God doesn't exist, right? Like you're like, oh well, yeah, time can't be relative because God doesn't exist. Einstein, don't you know that, bro? And because Einstein once said that he was trying to see the vision of God, everything he's saying must be wrong if God doesn't exist. Like that's really what his argument amounted to. Right?
He's misunderstanding how big knowledge is.
Humongous big.
He thinks it's a video game you can win the levels on and be,
Yeah, he's and again, I think he's used to going up against like these really fucking stupid people. Like this one guy, his IQ had to be like 80 or something. Like he was just like, bro, how do you explain like if I look out at the water, it's flat, it's just like a flat line and it goes forever, bro.
Someone said that the other day. They're like, actually, the flat Earth debate's really hard to argue against. I'm like,
because some of it is, it's like you're not even speaking the same language.
Well, how about the Earth does look flat?
Yeah.
I mean, if you only trust your sense experience, which unlike a lot of what these people believe is actually a valid pramana, then you could argue the earth is flat. It's just a question of what does that mean?
T-Jump's idea of more moralistic utopia. So what, he wants to be plugged into the Matrix?
Well, he has this just idea about objective morality, and it's just like, I don't know exactly what the point of it is, but it sort of made this pop into my head, and yeah, that's basically it's like, I don't know.
Yeah, what is
It's just becoming more bizarre because his followers are coming on and asking like more precise each time. They're like, you remember this time 3 weeks ago when you went into this line of logic and you may have contradicted yourself from 6 weeks ago?
Wait, so all right, so he's like developing, like I guess I knew he was popular because people were probably like, oh man, I like to see, I could see people watching just like, oh, I want to see like some Christ fag get demolished, but he actually has a following of like people wanting to know his philosophy or whatever. Like, well, that's a question. Does he have a philosophy?
He has an anti-philosophy, which the atheist will be quick to tell you is not the same thing as a philosophy.
Okay, well, so what is this anti-philosophy?
The Socratic method. He's literally the avatar of the Socratic method. Why do you think I've been going so hard on the Socratic method?
Yeah, but you're talking about the moralistic utopia thing. Like, what is that? What does he say?
He says objective morality is real, and I don't memorize this spiel exactly, but it's like objective morality is real. It's something about.
Oh,
like,
I think he was
everybody has
going
their own
into that
universe
with.
or something.
Did you ever watch the debate he had with Vosh?
No. I'm sorry.
Yeah, you might
What
want
was
to
it
check
about?
that out. It was about. I think technically the title was like Super Straights or whatever, but they kind of got deep into like, what does it mean to, what is it to be a woman, right? Like, they actually did get into the interesting aspect of the trans thing, which is, okay, well, you're defining these words and you're reconceptualizing womanhood as something.
Yeah, the whole self-referential
transcends.
thing, right?
Yeah, there was something about like, I'm redefining what blue means and blah blah blah. But like somehow that led into morals and
All right, guys, I'm out here.
I forgot you. I thought you left.
Yeah, I wouldn't leave without saying goodbye.
All right, man.
Are you
And,
down to do this? I hope you're down to do this again. No pressure if you don't want to, but I had a super positive experience, and I don't know how the audience feels. Please leave a comment. Encourage Aaron to get better.
First quadrant. All positive.
I think everything went really good though, and I would love to keep going because this to me is just like it's fun to sort of go and get a like little refresher course.
yeah, and you should give homework and like probably put in the description of the homework that you gave, so some other people could do their homework if they wanted to, and follow along, I guess.
Let's do it.
Full of entropy.
All right, man. And then we'll set up a time, whatever is convenient to you. And
Woohoo!
Thanks a lot, man.
My
And we'll-
pleasure. Blessings. Talk to you soon. Yeah,
Okay,
like I got on this fucking T-Jump debate Discord thing, and I'm having a convo with this one guy, and I'm just like, what the fuck? And at some point, I'm just like, okay,
I thought you
is
hated
it moral to
Discord.
punch yourself in the face? I
Send
literally
me,
just asked him point blank. I'm like, is it moral to punch yourself in the face? And he's like, he doesn't answer me right away, no. And I'm like, if your fucking morality can't answer me whether punching yourself in the face is moral, or wait, no, sorry, that's not right. It was should you punch yourself in the face?
Yeah, well, no, you shouldn't.
And I'm like, should you punch yourself? I don't remember exactly, but he couldn't answer it. And it's like, if you can't make a value judgment that's that simple, that it's not desirable to punch yourself in the face, then
yeah,
what are we talking about when we're like, have we just basically decided that morality means nothing and can be just completely arbitrarily defined? I guess that's the logical limit of cogito ergo sum. Cogito ergo sum leads to people thinking that they could just redefine stuff.
What is that in English?
I think therefore I am.
Oh, okay, right.
And it's just basically like they call it the cogito for short, but it's just this idea, I guess, that lends itself to this other idea that mental constructs are more real than they actually are. So this TJUB sort of LARP morality system was like, well, I define it as objective morality. It's like, really? Who
Yeah.
decides what's objective morality exactly?
I think I'm starting to see what you mean by that. But yeah,
Well, this is what it leads to, because now his followers are using the Socratic method on him, and he's forced to like produce these increasingly more ludicrous sounding things, which is like, well, everybody should just have their own, basically like the Matrix version video game life, to be able to do whatever you want, and so you can never get hurt by anybody at the cost of never ever having any real connection to anybody. It's like,
I never want to be hurt again.
well, it's just like super sad, because I just want to be like,
Fuck
no,
you,
please don't
Stacey.
go into the Matrix. Like, I don't even know you, but I don't want you to go in. Like, what if I share family and everybody
Yeah.
stay out here with us? You know, it's already basically like, if you understand consciousness from the point of view of yoga, it's already basically like we're Daleks in a very real way. Like, we can't get out of our own minds. It's astoundingly like,
What's that meme where it's like the Joker? I think it's like Weed Gang or something, and it's like it'll say something like, "Oh, I did the coolest thing, and you don't get to participate because you rejected me." And it's like a name. I think it's Stacy. I'm not sure.
Stacy?
Because Stacy's like an incel thing, and this is not. This is like a joke. So I don't.
No, you lost me. Sorry, I don't even know what
Well,
you're talking about right now.
They might have been making fun of incels. It's like there's this meme where someone will make. It's usually like a picture of the Joker from the Jared Leto one, and it's like, oh, I'm having the greatest time now, and I'm like really rich and everything. And I bet Stacy wishes she didn't go with Chad. It's like the reason I'm bringing it up is because it's like you're saying that he was hurt by someone, and that's why he wants to go in the Matrix and not interact with anyone anymore.
Christianity, yeah. I guess it does a number on some people.
Yeah, he got hurt by Christianity.
It's okay. I got the tonic. It's just like, I got something scarier than that. Reincarnation. So I can displace the paralytic terror with an even more paralytic terror. So
hey, speaking of reincarnation,
did
you see that Mark Wahlberg movie Infinite yet?
I kind of want to, now that I heard that, but I don't think I did. I saw Looper. That doesn't really have anything to do with reincarnation.
Yeah, well, it meets your standard of like being really retarded, but it's all, at the same time. You love retarded movies, but at the same time, it is about reincarnation, so you'll probably get a kick out of it. If you do see it, yeah, maybe.
Check about reincarnation. Check. Sign me up.
Yeah, I think you'll appreciate it.
Well, I guess we'll wrap it up. Seems like a great place to stop. Did you have any final words for the audience before we turn in?
Check out Infinite, and I'm not being paid to say that. Yeah. Final words? I don't know. This is good. I like. I've always liked math. I've always liked trig, and I want to expand my knowledge. We're expanding our knowledge.
Yeah, thanks so much for being part of it, and I look forward to our next impromptu or not stream.
All right, yeah, we'll be in touch.
Talk to you soon.
All right. See ya.
Audience, thanks for tuning in, and if you have any suggestions for subjects sort of related to this, we'd be happy to explore them. There's a lot of directions we can take this stuff, so it's hopefully going to be loads of fun going forward. Thanks all who tuned in. See you next time.
Yeah, but
Bye-bye
that's
for
just
now.
so to say, a worthless opinion of.
It's so important that she can't be told, she won't be told that it's wrong. And
bringing it back to Church of Entropy and her attack dog Gandalf the White.
Why don't you learn to shut up and fuck your goddamn logic?
they control the media, and the media is capable of making the sheeple believe in anything.
Yeah, I don't mind. I mean, we've had these streams, and I've been doing with Church of Entropy, and she's been bringing on new people, and like we did those streams on like stream etiquette. We walked through like the technology.
I have like very strongly negative opinions of the kind of Brundle clique.
Is she trying to garner herself cult prestige by associating herself